This is the second video on energy changes. So the last lesson we looked at, I had the two types of enthalpy changes. They are exothermic reactions and endothermic reactions. And what I had in there was, in the list for exothermic, was examples of an exothermic process is making bonds, and an example of endothermic processes is breaking bonds. So this video is going to explain that in a little bit more detail. When a chemical reaction occurs, the first thing that we need to do is break the bonds so that the atoms can then be free to rearrange themselves. It is logical that energy is needed to go in to break those bonds. If you can imagine it snapping like pieces of spaghetti pasta, you've actually got to use your bicep muscles to break that pasta. And it's just an analogy that I think of when I'm trying to think about bonds breaking. Energy has to be absorbed to break those bonds, which then makes these atoms free to realign themselves and be in the position where they can then form bonds. Okay, so takeaway message from this video is whenever we break bonds, it's an endothermic process, and it will be delta positive. Once your atoms are all broken up, then they can then realign themselves and form a new bond, and hence new chemical. The bond making process is a exothermic reaction. These actually release energy to the surroundings. So to sum up what we've just covered, whenever you break the bonds, it's an endothermic process. Okay, energy is absorbed, so the delta H is a positive value. When bonds form, then it is an exothermic process and energy is released, and so that is a negative value. Now notice that in this instance what we're doing is we're actually breaking what appears to be covalent bonds for new chemicals to form. But we can simplify this and just look at the melting and boiling process of water. So what we've got here on the left hand side is solid water. All the molecules are intermolecular bonded to other molecules, which holds the molecules close together. Okay, so these are the intermolecular bonds, these little dotted ones. We're not breaking covalent bonds when we're doing melting and boiling. But we are going to need to break some of these intermolecular bonds so that the molecules can spread apart a little bit, which is what they do when they go from solid to liquid. So we are going to be breaking intermolecular bonds. Okay, just those weak little intermolecular, and those little yellow circles there represent where the intermolecular bond is breaking, and they just break in some places. So to go from a solid to a liquid is a endothermic process. It is absorbing energy to break those intermolecular bonds. So you might get asked whether melting is endo or exo, and you will need to relate this back to the fact that it is a breaking bond process for the solid to go to a liquid. The next stage for a liquid to go to a gas. Now in a gas there are no intermolecular bonds. Notice all the little red dotted intermolecular bonds in this diagram are now gone. So the gaseous particles are all independent and freely zooming around. This again is an endothermic process. It is absorbing energy to break those intermolecular bonds. Now this applies to both boiling and evaporation, because don't forget, evaporation is liquid water going to a gas. In an example, water puddles outside in the sun. Okay, so you've got liquid water in the puddle, and as they absorb energy, they turn to gaseous particles and hence evaporate, and the puddles are gone. Let's look now at coming back the other way. So if you start off with the gas, and in order for it to go back to a liquid, we know that that process is called condensation. And for that to happen, you've got to go from being an independent little molecule moving around fast to starting to form intermolecular bonds. We are forming bonds, and anytime bonds form, it is a exothermic process because energy needs to be released. Okay, and you can think of it also, these fast moving particles are now not moving as fast. And likewise for the process of freezing, for the liquid to go to a solid, the particles are going to lose energy and form more of these intermolecular bonds and come closer together. You're forming bonds, and the forming bond process is always exothermic, so heat energy is released. In your SciPad, you've got this diagram, and it is the exact same explanation, just in a circular form. So you've got your solid atoms, particles, going to a liquid process or liquid phase, so the bonds are breaking, so it's endothermic. That would be delta H positive. For the liquid to go to a gas, it is again excuse me, a endothermic process because bonds are having to break. Coming back the other way, you are forming those intermolecular bonds, so it's now exothermic. Don't worry too much about this solid to gas step. There's only a few molecules which will do this. Carbon dioxide is one which goes from being solid carbon dioxide, which we know is dry ice, and it's sublimes. So all the intermolecular bonds need to break for it to go to gaseous carbon dioxide. The other substance that does this is iodine. It's an element, it's a purple solid, and it will give you a purple gas. And the reverse reaction is obviously going from the gaseous phase direct to the solid phase. So that is also going to be bond forming, so exothermic. So that's the end of video 2. I hope you found it useful. We'll see you in the next one.